do you guys know how the master slave circuit will work to avoid the race condition? So here is the thing that we can see how the master slave circuit will work here to avoid the race condition. So generally what the master slave circuit will do is that even for the level triggered flip-flops, even if we take the level triggered flip-flops, so these are all level triggered, that will be converted to edge trigger. So let me explain how that is happening. So here the both the things are level trigger, but you will be seeing that are converted to edge trigger. So let's discuss how that is happening. So that will be converted to edge trigger. Okay. So one thing the difference is that the clock will be inverted to slave and clock will be directly given to the master. So okay. So this is the circuit that for the master slave JK flip flop configuration. So it is used to convert level trigger to edge trigger. So as we discussed, right? So we take level trigger flip flop, but it will work as a edge trigger. So that is one of the main advantage that we are taking. So we already discussed when we take the edge trigger flip flop, the race condition can also be avoided. So in master slave JK flip flop, two flip flops were used. So one has act as a master and other as a slave. So why they acted as a master slave, that I will let you know. The clock is directly given to the master and it is given through an inverter to slave. So here we are used inverter. So master changes according to input when clock is 1, but slave will change whenever there is clock is 0. Slave output is the final output. So truth table is same as JK flip flop truth table. But the thing is that there is some quite difference will happen that I will let you know now. So in master slave JK flip flop, master works like positive edge trigger because the one is directly connected. So master will be acting as a positive trigger. So that is positive edge trigger. So even positive edge trigger. So similar to the positive edge trigger, it will happen. Okay. But slave that will be triggered as a negative trigger because that is given to a inverter, right? So that will act as a negative edge trigger. Okay. So we can say the master works like positive level and the slave works as a negative level. Okay. So in master slave JK flip flop, master changes only one at a clock whenever there is a only once when one clock. So it can be at the edge or at middle of the clock, but only once in one clock. Okay. Hence master can be treated as both level trigger or edge trigger because the master flip flop can change at any time. So whenever there is a transition from 0 to 1 or even at the middle of the one level. So master flip can be both. But the slave, hence the master can be treated as both, right? So in master slave JK flip flop, when J and K which is equal to 1 and clock is equal to 1, master toggles during the time when the clock input to the slave is 0. So here let me use a red pen. So when clock is 1, J is 1, K is 1. Then what will happen? Here the QN will be toggled. But on the time the output to here will be 0. So clock is 0. So nothing will work. So this is a clock pulse, right? So nothing will work. So there will be no change in the output. So the slave cannot transfer the data from the master to output. Okay. So when the clock becomes 0, so let me use the blue pen. So when the clock becomes 0, the clock input to slave is 1. So then only the clock input to the slave is changed to 1. So the slave transfer master data. By the time the clock input to the master is 0. Okay. So here the value to the master, this is 0. Right. So what will happen? So master cannot further change this condition. So this will be stayed there. So slave cannot change further. So only there is only one changes when one clock. So there is no RAS condition. So only one change in one clock pulse change. Only one change in one clock. Okay. So this can be now clearly indicating that there is no RAS condition. So there is no multiple change when for the even for the single input change. So we have completely avoided the thing, right? So we don't need to maintain any TWP, pulse width or any kind of clock duration, anything. So even with a simple master flip, there is a change in thing. We have achieved the thing that there is no RAS condition. So this is how master flip flop works to avoid the RAS condition. So now you guys able to get the thing, right? So whenever there is an input to the clock 1, the master flip flop will work. On the time slave is off. So whenever clock is 0, then slave will work, but master will be off. So that there won't be any further changes. So only one kind of changes only will happen. Okay. So continuing to this, let's start with our discussion on next flip flop, that is D flip flop. So you guys may ask a question. So even the JK flip-flop, we have avoided all the conditions, like all the disadvantages are removed. Then why we need a D flip-flop? So this is a good question. But the thing is that each one has its own benefit. So similar to that, the D flip-flop has been invented. So we no need to worry the internal structure of D flip-flop for now, because the D flip-flop will do nothing. So that will just transmit the data which is coming inside to the output whenever there is a clock in. So these are all the things that is just act as a wire. So when we on the switch, the electron will flow, right? So similar to that, whenever there is a clock input, the D in will be transferred to D out. That is what the D flip flop. So D flip flop won't do anything. Okay. So this is a simple structure. For this level only, they invented it. So there is only one input to this. So even that is more simple for us to do our calculation. Okay. So you guys can easily solve this one. So this is clock. So this is D in, and this is q n plus 1. So whenever clock is 0, what are the output? There will be no change in the output. So whenever clock is now itself we are considering only edge trigger flip flop. So in JK flip flop only we consider both level trigger and edge trigger, but in D flip flops we will consider only edge trigger. So that only we have mentioned like this up arrow. So when input is 0, output will be 0. When input is 1, output will be 1. So that is what the thing. The characteristic equation will be very simple. There is no need to find anything. So q n plus 1, which will be directly equal to D. So q n plus 1 will be directly equal to D. So this is what the characteristic equation. Okay. So excitation table will also be nothing. So let me draw it directly. So you guys can consider this is one of the very easiest flip flop. So q n plus 1 D. So 0 0 0 1 1 0 1 1. So whenever D to D change, input will be 0. When D to 1 change means input is equal to 1. So 1 to 0 change means 0. So 1 to 1 means 1. So q n plus 1 will directly come in q. So this from here we are getting here. So from this we are getting this one. So this is what the relationship that we have to use. So similar to the D flip flop, we have a T flip flop. So as the name suggests, this is a toggle flip flop. So you guys may ask why this is needed. So previously we see the wire connections. So whenever there is a clock input, the output will go. So here there is whenever the clock pulse, that will be toggle. So output will be toggle. So for that purpose, we are analyzing the T flip flop. So this will be the last flip flop. So you guys can chill now. So here the clock pulse will be given. So input T, output will be Q bar. Sorry, Q and Q bar. So this is T and this is clock. So this is T flip flop. So from here you can directly write a truth table like previous one. So whenever there is a clock input, input T is equal to 1, then the output will be shifted. Output will be toggled. So here clock T q n plus 1. Okay. So whenever clock is equal to 0, whatever may be the condition, the output will be maintained same. So whenever clock is edge trigger, whenever T is there, the Qn will be there. So whenever 0 is there, Qn will be there. So whenever 0, 1. So when 0, Qn will be maintained. So when 1 is applied, Qn will be toggled. So that is what the thing. So here the characteristic equation how will be, this is similar to XOR gate, right? So I am directly writing. So Qn plus 1, which will be equal to T XOR of Qn. So whenever previous state and input changes oppositely, output will be 1. So that is what the thing that I am there to represent. So the excitation table will be similar to this one, that this excitation table will be nothing but XOR table output. XOR table, truth table is that one. Excitation table. Okay, so Qn plus 1 T. So 0 0 0 1 1 0 1 1. So whenever 0 0 is there, output will be 0. Whenever change is 1 1, and output will be 0. Okay. So this is first, this is second. So three things you have to remember. So this is what the order. So we have completed all the flip-flop analysis. So now I think you guys will be having a good understanding of all the things. So continuing to this, let me ask you one question to test yourself. So I will be showing a circuit below where So let me first draw the flip-flop. So this is also one of the great previous year asked question. So here the thing is that, so this is J, so this is K, so output will be Q and Q bar. So clock will be given, so this is clock. Okay, so J is always 1. K is the thing from here which is connected to K. So K is connected to the output. Okay, so K is connected to the Q. So Q bar here, that is simple. Okay, so this is Q bar. Okay, so similar to JK flip flop. So here they are given the condition that Q which is equal to 0, which is the initial condition. So which is the initial condition that they are given. So what shall be the sequence of output? So they are asking us the sequence of output. So what will be the sequence of output that will be present here? Okay, so we are starting with the initial condition, that is 0. So if it is 0, it will come here like this. So let me use the red pen. So the thing is that if it is 0, then it also here it is also 0. So whenever the jk which is equal to 0, then how the things stand? So we know the characteristic equation, the curve n plus 1, n1 plus 1, which is equal to j qn bar plus k bar qn. Here we can clearly state j is always 1. So k which is equal to qn. So if we supply these things, so j which is equal to 1, so qn bar plus this will be always equal to 0 because kn is equal to qn. So qn into qn, that will be equal to 1. So this is what the condition. This is k bar, right? So k bar q1. So this will be get reverse. So the condition is that output will be toggled every time. So thing is that, so when first it is 0, then that will be changed to 1, then it will be changed to 1 0 1 0 1. So this is would be the output. So output will be repeatedly changing like this one. So from the characteristic equation, we can clearly able to find the q n plus 1 will be keep on changing for every clock changes. Okay, so this is how we can directly find everything, guys. So this is how we can solve the questions. So one more thing also we have to take into account, that how the frequency division will happen. So whenever there is a toggle in a circuit, this will happen. So let me take a clock pulse. So clock was initially at 0. So then it is changing to upper level, again coming back. So clock is lowered. So clock will be sequential like this one. So let me draw three clock pulses. Okay, so here is the 3 clock pulses that are taken into account. So one is this one. So next clock pulse, third clock pulse. So this is how clock will look like. Okay, so here we are going to see the frequency division. So here, whenever the clock is going up, the q naught is also going, q is also going. So q is going up. Okay, but again when the clock will when the output is going down is that when the next trigger is coming. So this is the time where again the thing is going down. So whenever there is a upper transition or edge trigger that is happening from 0 to 1, then only the state is changing. Okay, so if it is happens or persists like this, so here we can clearly see, so this is the actual duration of t. But here if you see the actual duration, the one up and one down, that duration is double. Okay, so here you see, so this is the t, but here there is increase to 2t. So this is happening. So t naught which is equal to t naught which is coming as 2t, so which is increasing in the output. So this is a q. So then what will happen is that the f naught, the output frequency, output clock frequency will be divided by 2. So that is what the thing. So this condition is termed as frequency division. So when we are giving the input, the clock pulse is changing, but for 2 clock pulses only, for the two clock pulses only, there is one change in the output. Then if that is happening, then the f clock will be divided by 2. So that this is the frequency of change in output. So f naught, it is nothing but the change in frequency in resembling to clock pulse which is changing. That is what we are calling as a frequency division. So based on number of bits are toggling, so we can state this. When flip-flop is connected in toggle mode, it will act as a frequency division. So when flip-flop is connected in toggle mode, so when flip-flop is connected in toggle mode, so this is one important question, please make note it. So when flip-flop is connected in toggle mode, so this will be acting as a frequency divisor. So this is very important, guys, so please make it note. Okay, so from here I am stopping this lecture here. So we have completed all our flip-flop understanding. So from here you are good at, and you guys are master in the flip-flop understanding. I thinking the same. So if you guys able to understand, please comment in the comment section as heart or any kind of things that you guys have understood or any doubts is there. So please post accordingly so that I will be get to know about your understanding levels. Okay guys, stay tuned. Next lecture we will be discussing some more things there. Thank you.